Hi, now let's try to do one problem. In this, two rollers, each of weight 1000 Newton and of radius 25 centimeter, each rest in a horizontal channel of width 90 centimeter. So, find the reaction on points of contacts A, B, C and D. So, here we have the problem by which it has two rollers and it is touching at each point A, B, C and D, and the width of the channel is, this one is told, this is 90 centimeter. The width of the channel is 90. This is 90 centimeter. The radius of each roller is taken as, say, I'll take it from here to this side, 25, and from here to this side again 25. Each roller is 25 centimeter long. So we will treat this as three different sections. Treat this problem as, first thing we need to find is, we need to find the angle of the each, this ball, this. So what we are going to do is draw horizontals and in each through the center of each ball, and join this two centers join this, and you can drop a perpendicular from here. So we need to find this theta. So that is the first stage we need to cover. So let's do that first. So I'll redraw. We need to first of all draw this. We need to draw this and drop a horizontal. Okay, so you need to draw. You should have two horizontals, one here, and drop a horizontal, and you have this theta. We need to find this theta. So as we have studied according to alternate angle theorem, so we know, again, this is what? This is again theta. Okay, so let's find this theta. We know this length, total length is 90 mm, 90 not mm, 70 centimeter, and we know the radius is 25. So suppose we need to find this here to here, this length. If we need to find, the easiest way is you reduce 90. We know this radius. This one you reduce. If you want to find this length, this one you reduce. So 90 minus 25. So I want to find. I'll name it. That is, I think, easier. A, B, C, D is there. Then so that this is E and F. Okay. So EF, if we need to find, type EF is equal to 90 minus this radius of this ball, that is 25. So minus 25 minus we need to find we need this distance. So this distance again 25. So from here to here. So again minus 25. So so which is 40 centimeter. So EC is equal to, sorry, EF is equal to 40 centimeter. Okay. So as we know, cos theta is equal to adjacent side by hypotenuse. Hypotenuse we can easily find. This is our radius. Radius is 25. So this 25 plus this 25. So the total it will be 50. So so this is our hypotenuse. This is our adjacent side. So adjacent side is equal to 40 divided by say 50. Hypotenuse is 50. So we can cut these two zeros, and 44 by 5. So we need to find theta now. So cos inverse 4 by 5 is our theta. So, theta is equal to cos inverse 4 by 5. Okay, so theta is equal to cos inverse 4 by 5, which is equal to 36.86 degrees. So we got the theta. So now we know, we draw horizontal, and if this, we know these are the the radius or the reaction forces, we can say, okay, this and say this theta, this is theta, and this theta is 36.86 degrees. Now let's look at draw the free body diagrams for each let's draw the free body diagram for this particular problem. So let's draw it. Let's draw the first one, first free body diagram. You have the roller, okay, this is the center of the roller. You have a reaction force from A, which is called as RA. You have a self weight is there, which is acting downwards, 1000 Newton. You have a reaction force acting upwards, RB. You have a force which is acting from the ball, so again a reaction force, RD. Okay, so this RD is having, we found the theta. Theta is equal to 36.87 RD. So we'll draw the next ball, the free body diagram for the next ball or next roller. So this is your self weight acting downwards, which is 1000 Newton. You have your reaction force, RC. You have you don't have a reaction force from down, because your body is not touching, the roller is not touching below, so you don't have it. Then you have this RD, which is in the opposite direction. So this RD, this ball is pushing this side and this ball is pushing that side. So this RD is like this, okay, again RD, right. This is your free body diagram. Okay, now let's take a single free body diagram and try to deduce and see how the forces will look once it is made concurrent. This is concurrent force only once it is made in the form which we can solve. So let's draw the first one. So let's draw, you have the roller, so 1000 Newton, which is acting downwards, right, just 1000 Newton, and upwards you have your RB, and this angle you have a force acting this side, which is, okay, this is this one, this is theta. And you have a normal acting this way, this is RA. I'll try to draw that again. Have a board, self weight acting downwards, 1000 Newton, You have your normal force acting this side. You have your force from the ball acting this side. So this is RA, R, R, D, RA, RD, and this one is acting upwards, RB. So if you draw it, it will look like this. RA, we can put it on this side. RB, we can put it up. RA, RB, and you have your self weight, which is 1000 newtons acting downwards, and you need to have, yeah, this one RD, RD. So this is with respect to the horizontal, it is making theta. So this is how it is going to look. Okay, now let's look at how we can draw the components. First of all, we'll draw the forces, the free body diagram, and you have RA, going up is RB, so as the side, theta RD, and down, which is 1000 Newton. And it's always better to have this drawn, and to separate the components. That is always better, so that this is to avoid mistake forces. Cos component, sine component. Okay, so we'll do the first force. We'll take RA. So this one, RA, it is set 0 degree, so we know it's in the first quadrant, plus you have both positive, so plus RA cos 0 and plus RA sine 0. We'll take the next one. Next one will be RB. So that is at 90 degree. So again plus RB cos 90, RB sine 90. This is we'll take the next one. So next one is RD. So this is making an angle theta of 36.87. So this is in the third quadrant, so both are minus. So minus RD cos 36.87, put a point, and minus RD sine 36.87. Okay, and we have the last one, which down, so which is again in the third quadrant, 1000 Newton. So which is minus 1000 cos 90 minus 1000 sine 90. Okay, so here we have our cos 0 is 1, sine 0 is 0, and cos 90 is 0, sine 90 is 1, and here again cos 90 is 0 and sine 90 is 1. So we can rewrite the same thing as okay, the whole problem can be rewritten as again, I think I need to draw that. forces. First one is R A. R A cos 0 is 1, or B is 0. So I'll put it as 0. Second one is RB. So RB is this, and is cos 90 1. So RB is there. Sin 90 is cos 0, sin 90 is 1, which is RB, and this one, both are existing, so both are minus sin RD cos, put it as theta, minus R sin theta, and the last one is nothing but 1000 Newton. So this is this 1000 Newton. Okay, you get it, minus 1000 cos 90 1, and sin 90 0. So this is 0. Okay, so you get suppose if you find sigma h is equal to 0, you get the first equation as RA minus RD minus 1000 is equal to 0, and this is for the horizontal, and you get one more equation, which is in the case of sigma v is equal to 0, you get RB minus RD sin theta the cos theta. This is cos theta, sin theta is equal to 0. Okay, now let's do the next one, which is we'll draw the forces. So RC acting downwards 1000 Newton, RB, this is at angle theta. So we found theta, we know the theta. Okay, so let's solve this one. So the components will be like this. Let's draw the forces, sin component, cos component, and solve this problem. Right. This is the forces. I'll put it as F. We'll do for RB first. So RB. So RB. So take it as RB cos theta, RB sin theta, this is RC cos 0, and the cos 0 is 1, and RC sin 0 is 0. So this is will turn out to be 0, sin 0, and finally this one 1000 Newton. So and here the sign is for x it is minus, so minus RC, this is plus. Okay, so this is minus 1000 cos 90 minus 1000 sin 90. Sin 90 will turn out to be 0. So if you write the equation, sigma h is equal to, first equation will be RB cos theta minus RC minus 1000 cos 91,000. Okay, and sigma v is equal to RB sin theta sin 90 is 1 minus 1000. We can equate both sigma h to 0 and sigma v to 0. So this is how we treat equilibrium problem. So we can again write as R v cos theta minus RC minus 1000 is equal to 0. Okay, now the forces are resolved and we got 4 equations out of it for sigma h and sigma v. So it is 2 sigma h equation for each and 2 sigma each roller and 2 sigma v for each roller. So I'll write that we need to solve the equation one by one. So let's have a look. Let's write the equation. For the first ball, we got it as first roller. We got it as sigma h is equal to R A minus R D cos 36.87. Sigma v is equal to RB minus RD sin 36.87 minus 1000. This is for the first one, and the second, so which is this roller. The second roller equation, we got it as sigma h is equal to RB cos 36.87 minus RC sigma v is equal to RD sin 36.87 minus 1000. Okay. Now let's look at now let's equate sigma h is equal to 0, all sigma is equal to 0, and sigma v is equal to 0. So we get four equations. So what we can do is we need to see which equation can be easily solved. So we need to have I think this one we can solve. This is having only one factor to find. RD, if we find, this is how we solve it. We search for the equation which is having only one term to solve. So that is the first equation. So we'll solve this one. We'll find RD. We'll put that RD into this one and we find RA. Okay. Then we put again RD into this. We can get RB, and for RC we put once we find RB, we put RB here and we solve RC. So this is how we can solve it. So to start with, we'll do the first one. RD is equal to you bring first of all equate sigma v is equal to 0. So 0 RD sine 36.87 is equal to 1000. Okay, so then RD is equal to 1000 divided by sine 36.87. Okay, you get the value as 1666.6 Newton. So this is your first value. So now we know the RD. So once you know the RD, we'll put that RD into the next term which we need to find. So we can either put it here or you can put it here and find either RA or RB can be found. So let's do that. Control. Okay, so we know RD is equal to 1666.6 Newton. So we have our next equation, which is RA is equal to, I am just bringing it to the other side, so equating sigma h to 0 and bringing it to the other side. RA is equal to RD cos 36.87. So which is equal to 1666.66 cos 36.87 is equal to RA is equal to 1333.32 Newton. This is RA. Okay. Once this is done, we need to find RB. So we need to equate that equation. To again 0. So we'll that's the first section, and sigma v will equate to 0. So RB is equal to, I'll write down, we'll solve it. RB is equal to RD sine 36.87 minus 1000. Now, so plus 1000. So we substitute RD in that. So it's 1666.67 sine 36.87 plus 1000. Okay, so we get the value as is equal to 2000 Newton. Okay, now we need to find one more, which is RC. RC. So RC we know from the equation. RC is equal to, it is again RC is found from the horizontal of the second equation. So in sigma h of the we equate that to 0. So RC is equal to RB cos 36.87 degrees. So you get RB. We know the RB. RB is 2000. So 2000 into cos 36.87, which is 1600 Newton. So this is how we do it. So we RA is equal to, here RA is 133.3